when I was little.
This is going to be another long one.
My father was famous.
D. Marble.
He was the greatest samurai
So much to
in the
unpack.
empire. He cut off the heads of 131 lords. He was the greatest samurai in the empire. And he took me with him.
Last week I was blocked on Twitter by D. Marble. I sent him a link to my videos trashing his eclipse claims to see if he had any defense, and his response was to challenge me to debunk another one of his videos. Well, that wasn't his only response. He was smug and insulting, and he sent me some lame memes that I easily shot down. But he blocked me because he wanted to keep asking questions but not answer any, and I kept calling him out on it. So he flounced away. But he did issue a direct challenge, which was, debunk this. And I said I would. Now, unlike Daryl, I'm not afraid to answer questions. So when I say I'm going to debunk his video, I'm not going to dismiss parts of his video offhand or respond to a point with that he puts forth with a meme or a question back at him. I'm going to address every single point of his video. So this may take a bit, but when I'm done, you'll see that Daryl doesn't have a high school level understanding of science. And whether that's through ignorance, willful ignorance because this information is easy to acquire, or just stupidity, I don't know. But either way, he has no idea what he's talking about. Let's get to his video.
One thing that we have to deal with as flat earthers from the heliocentric enthusiast community is the idea that they always say that we have absolutely no evidence to support what we believe.
This is true. He has no evidence to support what he believes. None.
Well, I think I'd like to weigh in on that and do what I can to provide a little more evidence that supports this
He
idea.
thinks he has evidence.
Today we're going to be talking about the sun. You're going to want to hang out until the end for this one.
I love how smug he looks here. He really thinks he's got a showstopper of evidence at the end. He has no idea that he has no idea what he's talking about.
Now, what we're told according to the heliocentric model is that the sun is 93 million miles away. We're going to start off by talking about the distance. We'll talk about the size in a little bit. The thing is, according to what we see, these CGI images from the sun, we always see the solar system and it's never to scale. You never see a representation, graphical representation of the sun being 93 million miles away from the Earth and all the other planets, you know, in relation. You never see it that way. Every time the sun seems to be small and close, it's right at the center. There isn't a whole lot of distance in between the sun and the rest of the planets. Definitely not 93 million miles of distance in scale on these little CGI images.
In my previous video, I called him a small thinker, and this is one reason why. Right off the bat, Daryl shows he doesn't understand the reality of large distances. Why don't we see images of the solar system at scale? Maybe because we want to be able to see the planets? Remember a week or so back when I made a video showing that the eclipse debunks your flat earth model, Daryl? Yeah, well, in it I showed this image, a 2-scale representation of the sun, earth, and moon. There's the sun. Can you see the earth? It's right here. Let me zoom in. Give it a second. Here we are. What Daryl doesn't seem to understand is how big 93 million miles is. If I pull back again here, this is how well you can see the Earth if we show everything to scale. And that's just the 93 million miles between the Earth and the Sun. Neptune is some 30 times farther away. So the Sun would be a 30th its diameter, and nothing else would be seen. If the Earth were the size of a small marble, the solar system would be about the size of San Francisco. So let's spread out a big yoga ball and a bunch of marbles over an area the size of San Francisco. Back up and get a photo of it all. what would you see? What value would that be? That's why they don't show the solar system to true scale. Let's continue.
Okay. Also, another red flag in that whole idea is that it is CGI. The fact that every time you see the solar system, you see the sun and the earth in the sky and all that, out in space, it's always CGI. That should be a red flag. Okay.
No, it's not always CGI. These images here of the Earth are not CGI. They are single exposure film images of the Earth. Now, the fact is that all imagery from satellites of objects in the solar system taken today are digital. And all digital images come through some form of a computer. Hell, any image you see online has technically been processed by a computer. But that does not make them CGI. They're not necessarily computer generated. If a satellite captures an image of the sun in the infrared spectrum, infrared isn't visible to our eyes, so the infrared image is converted into wavelengths that we can see. So even though a computer converted it into something we can see, it didn't just generate the image. Now, some images are computer generated, for sure, but to say all is just lying or being ignorant of the facts.
Okay. The sun, if the sun is 93 million miles away, you know, we have these images, we have videos where the sun leaves a hot spot on the clouds or on the surface of the earth. As you can see here in this footage from DogCam, you see the weather balloon has a camera attached to it. It's floating above the clouds and all that, and you can see a hot spot. Now, if the sun were 93 million miles away, there's no way it will be able to leave that little spot there on the clouds, but right there you can see it. Or from this video that...
Where did you come up with the idea that hotspots can only result from a light source being close? Who told you that? A hotspot occurs because a great deal of light is being reflected toward the camera from a particular surface. That's it. Distance of the light doesn't matter. The fact is, if you look at this image, you see puffy clouds all over, which breaks up the light, diffuses it. But the point that has the hotspot is smooth and reflective, likely water. And so you get a lot of light bouncing straight toward the camera. Hotspot. It has nothing to do with distance. Whoever told you that about hotspots, they lied to you.
This video that I took personally from an airplane, you know, on a flight from Little Rock to Houston, you could see the sun seemingly right above the surface of the earth, and you could see this spot where it appeared that the light was that much more intense in that area than anywhere else on the surface of the earth. Now,
so you don't know how light works, do you? Don't you know that light is more intense where more is bouncing toward you? These areas here are getting just as much light as this area, but more of it is bouncing away from you, while this area right here is right in line with you in the sun, and more of it is bouncing towards you. Why don't you know this? Don't you have light bulbs? How have you not noticed this fundamental property of light and vision?
if the sun were actually at a distance of 93 million miles away, all the rays from the sun would hit the earth parallel. But the fact of the matter is, there's pictures, and you've seen these things more than likely, or you're seeing one right here, of the sun seemingly sitting right above the clouds where the rays kind of splay out into these different directions, showing where if you trace the rays back to this singular source, these are called crepuscular rays. If you trace these rays back to the source from each side, you'll see it goes straight to the sun, and you can pretty much triangulate the location of the sun using those sun rays. The only thing is, we've been brainwashed for so long to believe that the sun's so far away that when we see these rays, we'll say, that's just a coincidence, it's some sort of optical illusion, or the sun's actually at that distance, but it's refraction. Light works differently out there with the sun, when in actuality that's not the case. You know,
Of course. Crepuscular rays. Well, let's just say sunbeams. Yeah, you're not going to like it, but it's not refraction. It's just perspective. Parallel lines, when seen at an angle, appear to converge at infinity. Now, if this wasn't the case, if sunbeams really did show the sun nearby, it could be quickly proven. Use your math to get the position of the sun. Then call someone that should be under the sun according to your math and ask them where the sun is. I bet good money the sun will not be right overhead. But another proof that the light is parallel comes from images like these. These are anti-crepuscular rays, rays that show up on the opposite horizon from the sun. The sunlight comes in from there. That same light that you think is from a nearby source, it passes us by and then converges at infinity over there. They converge at infinity because they are parallel. If the source was nearby, the light would still be diverging, spreading out as it passes, and would not converge at infinity over there. Your model can't just explain some things, Daryl. It has to explain things better, and it has to explain more things than the heliocentric model. I could say, sure, the near-sun model might explain these rays, but it doesn't explain these rays, while the heliocentric model explains both. Oh, and when you see pictures of crepuscular rays from above the clouds, they run parallel.
as far as the temperature differences concerning the sun, you know, we're told we're in this Goldilocks zone. We're in this perfect space where we're not so close to the sun that we would actually burn, and we're not so far away from the sun that we would all freeze to death. You know, this wouldn't be like an ice planet. You know, so my question here, because I'm a simple guy, this is a simple question.
Yes, you are.
Sun's 93 million miles away. If we were any closer to the sun, we'd be on fire, right? So you'd like to think that everything within 92 million miles away would be ablaze, wouldn't you? Because that's what we're told, right? We're in the Goldilocks zone. If we were closer, we would be on fire, right? That's what the trusted scientific community tells us, right? I want you to think about this stuff.
Okay. In my nearly 50 years on this planet, I have never heard a single scientist say that if we were any closer to the sun, we would burn, or or be on fire, or any farther away, we would be an ice planet. Where are you getting this nonsense? No one has ever said that. You have this naive concept of the heliocentric model, where the Earth is going around in this perfect circle around the sun at exactly 93 million miles, and any closer or any farther away means catastrophe. Okay, so first let's talk about this word zone, which he seems to not know what it means. Here, zone means range of distances where conditions would be friendly to life as we know it, specifically liquid water and atmosphere to keep it. It's not about being on fire or being an ice planet. That Goldilocks zone is a decent size too. Venus crosses into it on occasion, and Mars sits right in there too. Now, Mars doesn't have much of an atmosphere though, but it is in the zone. No, there's lots of room to move around in the Goldilocks zone, which is good because the Earth doesn't stay at 93 million miles from the sun. No, it's got an elliptical path that takes them about 91.5 million miles out from the sun, and then out to about 94.5 million miles. So when Daryl wonders why the inner planets aren't on fire and the outer planets aren't all ice, all he's doing is showing that he doesn't know what the actual positions taken by mainstream science are. Moving on.
You know? Also, concerning the sun at that distance, realize this, try to acknowledge this fact that every time you see the sun out in space, you always see this big orange ball, and you see these solar flares, you know, just kind of jumping off the surface, and you know, it's all looks like hot lava. It's orange, this molten ball out in the middle of space, and behind this big orange ball, you always see this black background. The background is always jet black. But when you go outside and you look up and you see the sun looks like more of a yellow spotlight, small, local. And what do you see with your own eyes behind the sun? You always see blue. When you go outside and you look up at the sun, you see a blue background. So why is it that here on Earth, you look up and you see the sun, and the sun always has a blue background, but when you see these official images from the trusted scientific community and the good folks over at NASA who are raking in that $52 million a day, you see the sun and it's always a black background. Why does that happen? Why does it look that way? Ask these questions to yourself.
Okay. I was genuinely stunned when I first heard him take this position. Do you really not know why satellites images taken of the Earth have a black background while we see a blue sky when we look toward the sun? Or sometimes an orange sky. You don't know that?
Ask these questions to yourself.
No, instead I decided to ask my 12-year-old son Malachi. Without coaching, this is what I got for an answer. Hey Malachi, I have a question for you. Mm-hmm. Okay. So you know how when you go out in the daytime and you look at the sun and it's kind of like this bright yellow, white, and it's on a blue sky?
Yeah.
But when you look at the pictures of like from satellites of the sun and it's like orange up against black, why is it black when you look at there, but when you look at it up to yourself with your eyes, it's up against blue?
Well, I'll say because when you look at it from Earth, the light is affected by the air and it makes it look brighter than in space. And also they probably dim down the picture when they take it.
Excellent. That's pretty good. He's 12 years old, and he knew the answer to that question. Was that a complete answer? No. But at 12 years old, my son seems to know more about how air affects light, creating a colored sky, than Daryl does. Dude, when you're on the Earth, you are looking at the sun on a planet with an atmosphere. It refracts and scatters the light and appears blue, sometimes red, sometimes orange. So when we're looking up, we're looking at atmosphere. In space, which is where the satellites take those images, there is no air, no light scattering. You are looking at the vast nothingness of space. And my 12-year-old even knows that the sun is so bright that the images we see have been filtered as to not be too bright, to allow us to better see the sun's features. And when you filter out light, the bright sun, you also filter out the dim stars. So even those go away.
You know, the size comparison of the Earth goes as follows. They tell us that the Earth is 400 times smaller than the sun. Vice versa. The sun is 400 times larger than the Earth, is what they tell us. By comparison, looks a little something like this. Now, there's also video representation where there...
Hold on there. Daryl, who's telling you the sun is 400 times the size of the Earth? Did you bother to look that up? Where did you get that number? First off, the diameter of the sun is 109 times the diameter of the Earth. 109, not 400. But that's just the diameter. When it comes to volume, the sun is 1.3 million times the size of the Earth. That means you could pour 1.3 million Earths inside the sun. Neither of those numbers is 400. Where do you get 400?
There's one pilot. He shows that he's flying at 35,000 feet. And what he does, he takes his camera, shows the controls, shows his altitude, and out of the window on the right side, he shows the moon off in the distance, and it's nice and dark. And what he does, he pans his camera around to the left over a seemingly flat surface because you can't see any curvature at that 35,000 feet. And then he shows the sun. And the sun in this video looks small, looks local, it looks like it's sitting right above the clouds. You know, but there's also...
Okay. It's called a sunset. It happens every night. The Earth turns and the sun sets below the horizon. Every night. You know that's a specific facet of the globe model, right? Now, I know this wasn't the point of your video, but let me speak to your claim about seeing the curve of the Earth at 35,000 feet. You know this plane is not 35,000 feet above the horizon, right? No, they may be 35,000 feet over the surface of the Earth, but that's not the horizon that we're looking at here. No, really. What we're looking at is the horizon made by the highest clouds below the plane in the distance. Right? The plane goes up, the surface of the Earth falls away. But when the plane goes above a cloud layer, that becomes the new floor. You can be up 35,000 feet, but if you're only 1,000 feet above the clouds in the distance, then you're only 1,000 feet above an even bigger sphere. I can guarantee you've never thought about that.
Another video from a pilot where he shows the controls at 38,000 feet. What does he do? He gives a big thumbs up, smiles at the camera, and it cuts to another clip from that same cockpit. And the camera shows the clouds out of the right side of the window, I believe it was. And over these clouds, inside these clouds, you see this large orange bright object. Now, they're at 38,000 feet. You can see that it would appear that the sun is not up in the sky, but perhaps that, from this evidence, it looks like the sun is in the clouds when he's flying that airplane in that particular video. There's more evidence.
Another video with either a sunset or a sunrise. Daryl doesn't realize that the heliocentric model allows for the sun to be below the clouds. Let's call this the Earth, and the sunlight is coming in from this direction. If this is you here, and there's a cloud overhead, you're in the shadow, and the sun is bouncing off the top of the cloud. If you're in a plane above that cloud, it's bright and reflecting. But if you're here where it's sunset or sunrise, actually just past sunset or just before sunrise on the surface, even though the sun is below the horizon for someone at sea level, for this cloud here, the sun comes in and hits the underside of the clouds, making the clouds glow like in these photos. Now, if you're in a plane above those clouds, you see the sun through those clouds and you see the glow coming through. It's really quite simple if you take the time to think about it.
For a close, small, local sun, there was a guy on the beach where he talked you through his video, and he said, I knew that this was going to be a good day to get a good video of the sun with clouds behind it on the beach. So he took his P900 and he zoomed in on the sun, and you could see clouds behind the sun, signifying that the sun is not 93 million miles away or 400 times the size of the Earth. And if you actually just trust your senses,
Nope, that's not the clouds behind the sun. That's the clouds in front of the sun being washed out by the sun's intensity. If you were to be absolutely honest, you'd have to admit that you don't actually see the clouds go behind the sun, but you see the clouds run up to the edge of the sun and then disappear and then kind of reappear on the other side. How does that work? Here, let me show you a picture here. Start off with some nice thin clouds in the distance. See how they move around? Then they pass in front of the sun, which is so bright that the clouds cannot be seen. It gets washed out. Maybe some highlights glow around it here. Now, closer to you are these thicker clouds, and the sunlight doesn't make it through them. Shadows appear in the clouds, resulting in this layered look. The sun is far and bright, and the clouds are thin.
If you can hop on YouTube, or you can, take a look at this video and find additional videos, you're going to find that there are time lapses that people have taken of the sun moving across the sky. And while the sun's moving across the sky, you'll notice that the Earth seems to be stationary. Like, the Earth isn't moving, the buildings that you see aren't moving. You see the sun drifting across the sky. So what does that tell you?
It tells me you don't know how anything works. Do you not understand that the camera is attached to the Earth and they are moving together? Hey Daryl, here's a dash cam video. Why doesn't the front of the car move? Because the camera is attached to the moving object and is moving with it. Do you really expect the Earth to be moving relative to the camera? The camera's on the Earth and moving with it. How do you not know that, man?
We're told that the Earth is rotating around the sun, yet we feel no movement. We don't see any motion. We don't feel any motion out here. But we feel stillness when we go outside. And in the time lapse, you see the sun moving across the sky just like that. So what does that tell you? I believe that tells you to trust your senses. And what does your senses tell you? Your senses tell you that the sun is the thing that's moving and that the Earth is flat and stationary. But let's go on.
You don't feel the Earth moving. Trust your senses. How to address this? Okay, for some people, like Daryl, they think that their senses are really good, when in fact they're pretty dull. They think that since the Earth is spinning, we should feel like we're moving fast. But our bodies don't feel speed. No, we don't feel speed. We feel acceleration. But if our speed is constant, we don't notice the motion. If you're in a car or on a train or a plane that's moving smoothly, you have no idea how fast you're going. Without visual cues, you can't tell. Now you say, but I can feel that I'm moving, Jerry. I always feel it. What you feel is the bumping and the vibration of the engine, the road, the tracks, the turbulence. And each of those bumps is an acceleration. But you have no sense of speed without visual cues. That's how simulators work. By fooling your senses. Slowly dip the box you're in and shake it and make you feel like you're accelerating forward. Then rumble you a bit and show images going by very quickly. And you think you're moving fast. But you're not. And you can't tell. Simulators use the fact that we can't tell how fast we are going to convince us of motion that isn't there. Now some of you out there may know a bit of science. Not you, Daryl. You'd never think of this. But some of you may be thinking, wait, since the Earth is spinning, I'm traveling on a circular path. I'm not going in one direction at a constant speed. I'm changing direction at every moment. And that change of direction is acceleration. Why don't I feel that acceleration? Well, it's possible we would, except for the fact that that acceleration is overwhelmed by the acceleration we do feel, the acceleration of gravity. You see, gravity is accelerating us toward the center of the Earth at all times. The ground just gets in the way. And we feel that acceleration at all times. That's how we can tell up from down at all times. We're just used to it. We were born in it, and it's always there. We tend to ignore it. And that little fraction of acceleration of the Earth spinning, it barely touches gravity. We don't notice it.
Now, I was thinking to myself the other day, concerning the sun, that in our graphical images, say Google Earth, things like that, we're shown the Earth.
Oh, okay. The rest of this is too slow. But this was the big stunner at the end of his video that he was so proud of. Given that the sun can only illuminate half the globe at any one time, he decided to test the globe model by calling his fellow flat earthers in Yorkshire and in Queensland by Skype, so you can see that the sun is visible in both places, and his local Washington at the same time. Well, they don't really see the sun, but the sky is lit up by the sun. The guy in Yorkshire says he can still see the rays, and the guy in Queensland says the sun is just coming up. So neither of them actually say that they can see the sun, and the video is just bright. But they acknowledge that the sun is over there and lighting up the sky, and I acknowledge that too. Now, given those locations are 15 time zones apart, he thinks this proves the heliocentric model has been shattered. What it actually shows that, once again, he has an elementary school understanding of the heliocentric model. But before I go on about his failure of education, there's this part. As I was writing up my deconstruction of his other nonsense, he put up another video defending himself from criticism. People say he faked it somehow or something, and I don't think that's what happened. What he did was real, but he just didn't understand what was happening. He defends himself by setting up a globe with a light and shows that these two locations cannot be lit up by the sun at the same time. And I'm glad he did that, because my criticism was to show that he doesn't understand how the heliocentric model works, and his demo proved it. He sets the Earth up, and you can see he's unable to have light on both Yorkshire and Queensland at the same time. That proves it, right? Let me set up a similar demo. this is how he had it set up. My Earth, like this, my sun over there. In this case, my sun is smaller than my Earth, so it will illuminate a little less than half of the globe, while the real sun, being bigger than the Earth, illuminates a hair more than half the Earth. But we work with what we have. Now, I have an old-ass globe, and it's not very reflective, so bear with me. But I have the location of these 3 cities on it here. As you can see, when the UK is at sunset, here, Australia is in darkness. And this is why Daryl thinks he's right. So, here's the thing. It's summer in the United States, and the seasons are determined by the orientation of the Earth on its axis in regards to the sun. And since it's summer, that means the northern hemisphere is pointed toward the sun like this. Now, in Daryl's video, he claimed that no part of the Earth should get more than 12 hours of light. As you can see here, places on the globe that are far north have longer daylight during this time of year. Anything more north than this will have 24 hours of light. Right now, Yorkshire's daylight hours are over 14 hours. A few weeks back, they were 16 hours. In Tacoma, the days are 13 and a half hours long because it's here. Not as far north, but pretty far north. So while only half the planet gets light, the half that is at this angle during this part of the year has more daylight hours. So let's look at our locations, shall we? Give me a moment. Here we have Yorkshire, and it's dawn. And as the day passes, we get to peak sun, and now we're at sunset. The sun has gone down, and all you see is a glow from the sunset. In Washington, you can see its peak sun. And over here in Queensland, down there, look at that. The sun is just making the sky glow. Huh. It's almost as if, once again, Daryl doesn't know what he's talking about. Now I see why he has this self-assured smile on his face all the time. They do say ignorance is bliss.
That's my job! That's what I do! I don't lose! I win! Is there no one on this planet to even challenge me?
Maybe you came by to congratulate me on last night's victory.